Okay, so now I start the session for today. Students, can you listen my voice?
जी सर.
Yes.
Yes, sir.
Okay. Okay. So in the last lecture, I was at this point Ascii code and Ascii keyboard for computers. Actually, we know that the assembly language and machine language is different for different devices. So the ASCII code conversion for computer is different from the code conversion to for the microprocessor. So we generally use ASCII keyboard, that is standard uh, American standard code for information interchange, that is code inside the keyboard. Suppose we are entering any number written on the keyboard, so it will not directly enter the that number or symbol. It will enter in terms of some hexadecimal code. So microcomputer, video screen printer, all these type of uh, devices are used using the ESCII code for input. Okay, so this is basically the 7-bit code that defines 128 configuration to raised power 7, and these 128 combinations involve letters, decimal numbers, symbols, and machine commands. Okay, so one another ASCII code is extended ASCII code that involves 1 bit extra, that is 8-bit. So this has 256 combination, 2 raised power 8, and additionally 128 combinations from previous ASCII code is added, that is for graphic characters. So here we have the ASCII keyboard for computers. Here 0 to 9 are assigned as the ASCII character 30 to 39 in hexadecimal equivalent, or in binary equivalent ASCII character is 01100 to 00111001. So the equivalent of hexadecimal has been changed in binary equivalent. You can see in the table. Similarly, some locations are reserved for A to Z letters. So A to Z letters are defined as 41 to 5A in hexadecimal equivalent, and which is also later changed in binary equivalent. Symbols are given from 20 to 2F H in hexadecimal. These are hexadecimal equivalent. So some initial commands are also there, such as carriage return and line feed, because carriage return and line feed are generally the commands which were used in the typewriter also. So now assembly language to machine language in MPU. This has several steps. One is hand assembly and another is assembler. Hand assembly has mnemonics to hex code, and once we did design the table of mnemonics to hex code, these codes are entered one by the hex keyboard, and then it is executed. Another method is the assembler, which converts the assembly language entered by ASCII keyboard into the equivalent binary information. So assembler is an automatic program which does not need to convert the mnemonics to hex code first and then entering one by one. Similarly, simply assembly language is entered by ASCII code, and the assembler program itself converts this uh, ASCII code to the binary equivalent information for MPU microprocessor. So we can see that this assembly language to machine language depends on machine to machine. So for computer, this conversion table will be different. For microprocessor, ASCII code to uh, uh, code uh, machine language will be different. So here we can see a lots of assembly language mnemonics and hex code for microprocessor. So just we enter a c I from uh, ASCII code keyboard, then what will happen? The simple mnemonics ACI will be entered, and then assembler will uh, generate the hex code CE for the microprocessor. So we have the ASCII keyboard, and then we have entered ACI in the microprocessor. Then it will generate the hex code for microprocessor, and it will understand that it is the this instruction. Okay, suppose we have CMPA. You can see here BF CMPA or B8 CMPB. So once we have given the command using the ASCII keyboard, the C, M and P letters will be typed from that keyboard, and this will convert to the appropriate hex code that is designed for microprocessor, and it will understand it is uh, trying to get the complementary of the B. So can you understand this table? Here you can see that some 8 to 8F, 86, 8F, these are reserved for ADC, 8. So different uh, memory locations are, the different hex codes are assigned for different types of mnemonics or instructions. Similarly, here also you can see the different instructions which are reserved. Hex codes are reserved. 52 is for move D to D. So now we come to the microprocessor architecture and its operation. So first question comes, what is the architecture? स्क्रीन विजुअल है ना?
Yes, sir, visible.
Yes, sir.
Okay. So microprocessor architecture and its operation. The logic designed for data manipulation and communication is called the architecture. So whole the structure of system, the data lines and address lines and logic design, this is called the architecture. So in this logic design and this whole structure of microprocessor, various instructions are there for desired performance, which are entered using keyboard into the memory, and the microprocessor reads transfers one instruction at a time and performs the data manipulation as per the instruction. The result can be stored or sent to the output devices such as LED and CRT terminals. So when there is instruction, the microprocessor transfers or modifies the data. Suppose there is a instruction for storing data at particular memory location, then there will be some signal, control signal and memory will be modify memory location given by that address will be modified and the new value will be entered there. So also the microprocessor can respond to different external signals. Suppose sometimes interrupt signals are there, so it will act differently for different types of signals which are handshake signals may be there. So sometimes the uh, any peripheral will ask for the uh, data at particular location, then that address location will be pointed, okay, and the data available there will be given to the required bus. So here you can see interrupt and reset and synchronization request. These are the different external control signals, external signals which has to be uh, responded by the microprocessor. So there are different uh, functions performed by the microprocessor. One is the microprocessor initiated operations, second is internal operations, and peripheral operations. So first is the microprocessor initiated operations. Here a physical view of the microprocessor board, which is generally used all over the institutes to illustrate the so the study the keyboard microprocessor. So here we have uh, microprocessor operations like memory read, memory write, input output read, and input output write. What do you understand by memory read? Anyone is any student can tell.
Whatever data stored in the memory, uh, microprocessor will read that.
Okay, so particular address is given to the memory location. Particular address is given, and at that particular address, when it is asked to memory read, when there is a signal of memory read, so the available data at that memory location for which we have given the address, that will come out in data lines. Similarly, memory write, whenever there is a memory write signal, then the data in the data bus will be written at particular memory location for which the address is given in the address line. Similarly, input output read, we can give the input from different input peripheral devices, and when there is a signal for read, the data from input device will be stored in particular location of that device. Suppose device is connected, device has reserved the particular location, particular address in the memory. Then whenever we enter the value from uh, input, that data will be written on that memory location. Uh, so sorry, input output read is for output, and input output write is for uh, writing the data inside the memory. Okay, so we can take the data from the memory, and we can also give the data to the memory to store. And so we can see that memory address lines are just unidirectional, and this memory read and memory write, that is data lines are bidirectional. So we can have both the read and the write operations at the same time, so data can flow in either directions. So there are three different steps to communicate to peripherals. First is identify the peripheral or memory location. Suppose at which memory location the data has to be transferred or data has to be manipulated, and then transfer binary information or data and instructions, and provide timing signals and synchronization signals. So timing and synchronization, what is timing and synchronization? Once we have memory location or peripheral location of peripheral identified, for the data transfer a signal will be given. So all these three steps are necessary for uh, communication to peripheral. So 8085 bus structure, there are three different buses, that is address bus, data bus and control bus. Address bus is a 16-bit unidirectional line, that is A0 to A15. So each line may have 1 or 0 which may change with the time or depending on the configuration of A0 to A15. So suppose 16 bits are there in address bus. So 16 lines will be there and 2 raised power 16 locations will be uh, uh, 2 raised power 16 address configuration will be possible. Okay. So suppose in waiting system, when we call any person, suppose token number 10, the particular person comes and goes to the counter. In the same way, when the particular address is kept in address bus, the information related to that is communicated to the data uh, bus when it is the signal for memory read, or the particular data from the data bus will be stored in a memory when there is a signal for memory write. So this is a type. Address bus provides the token. In a similar way, you can also assume address address bus as location for house. Suppose we have a colony and we have the houses, and we can either take digit system for allocating the houses, or we can also use the 4-digit system for allocating the houses. Suppose our house is 45th, then we can also assume that 0 to 9, 00 to 99, we have only the capacity to allocate 100 houses. So 45th house will be given by 4 5 2 digits only. And when we have the uh, 4 digits, suppose 0045, then there will be the digit system will be 000 and 9999. So higher the number of address lines, higher is the capacity to identify the memory locations. So 16 address lines is capable of addressing 2 raised to power 16, that is 65 536 memory locations, or generally it is called the 64K. Okay. So students, is it clear to you now? Suppose 45th house is there, so we can also take it as 45, or we can also take it as 0045. 45 is in case if we take the location 00 to 99, and 0045 is when we select the 4 zeros and 4 9s. So in case of 4 digits, we have a larger capacity to identify different postal addresses of houses. In the same number, in the same manner, we have, if we have higher address lines, higher memory locations higher number of memory locations can be identified. So we can also use the 5-bit address bus or 4-bit, but to keep the 8085 bus structure, 8085 system, large memory locations, we have only 16-bit unidirectional lines used in this 8085. So next is data bus. Data bus is of 8 lines in 8085. This is bidirectional. This can the data can be either flow from the memory to the data bus, or from the input device to the data bus, or from the data bus to the output device, or from the data bus to the memory. So we've seen that there are bidirectional flow from the memory and database to memory. So this is the bidirectional lines. So the data flow may be both the directions. 8 lines contains one bit per line, and because there are 8 bits, so 2 raised power 8, that is 256 configurations are possible, that is 00 to FF. So you can see here, I will show you one thing. uh, Here you can see that this is the 205. You can see here simple structure of memory locations: 2031, 2032, 2034, 2035. So 2030, 2031, these are the four, uh, 4 into 4, that is 16 bit address line. 16-bit address: 2030, this is 2030, this is 2031, this is 2032. So this is 16-bit address. Okay, and here in each address you can see that there are only possible two uh, two digits. So this can be 00 to FF. We can enter any value here, 00, and we can enter any value here, maximum FF. So 00 to FF is total 256 configurations. So we can see here, this is the 8-bit and this is 16-bit. One data is 8-bit and one address is 16-bit. Okay, so is it clear? Some other microprocessors are also there which use 16-bit data lines, जैसे Intel 8086, Zilog Z8000, and Motorola 68000. These all have 16-bit data lines. So they have larger capacity to deal the different patterns of data. And Intel 80386 and 486 have 32-bit data lines. So they are called the 32-bit microprocessors. So now we come to the control bus. Control bus are various single lines. Why this is the single line? We can generally be confused with the data bus and address bus, that bus means combinedly all the lines together. But here, even it is a large number of wires may be emerging from between the controllers and various timing units, but only only one line will have signal for particular operation. Okay, so these are the I am connected or not, because just I have a call, and due to call some connection issue may be there also. Am I connected? Can you listen my voice?
Yes, sir.
Okay. So only single line will be activated once for a particular operation. Suppose memory read have one line only activated, memory write will have activated only one line. So this is single line activation, okay, in control bus. So this can carry the synchronization signals for different uh, clocks, different operations. It can provide the timing signals also. So uh, microprocessor generates a specific control signal for every operation. Means the control signals are generated for a particular operation by the microprocessor itself, and there is a control logic inside this microprocessor. So at particular timing, when we will ask to store something in memory, then there will be a timing signal automatically generated in MPU for generating a memory read memory write operation to store some data. So this is automatically done in microprocessor, and signals are given at particular time. Uh, and these control signals can also identify the devices from where the data is to come, and from where to where the data has to go. So जब इनको पता होगा कि सिग्नल कहाँ से आना है, कहाँ जाना है, ये भी पता होगा, तभी तो कोई पर्टिकुलर डिवाइस है, मेमोरी रीड है कि डाटा रीड है, इनपुट आउटपुट रीड है, कौन सा है ये पता होना चाहिए. तो मतलब कंट्रोल एल्गोरिथम, control bus can provide these signals. Okay, so what are the different steps? Suppose any data manipulation in memory has to be completed, then what is the step? So first step is to read the instruction from memory location. Suppose we have given at a particular program counter location, we have given a particular instruction, then this instruction will be read. And suppose this instruction provides some information to load the data from particular location, then microprocessor places a 16-bit address on the address bus, and this address bus, the data available at that address bus will be identified. Means at this address this data is available. Now when the microprocessor unit sends a pulse called the memory read, this activates the memory chip, and the data 8-bit content of that memory location are placed on the data bus. So here you can see uh, just uh, we have given the address 2051, suppose. Okay, when we will give the 2051 and a control signal, that is memory uh, read will be there, then our data bus will have the data ff, because the ff at that location 2051 will be coming to the data lines, data bus. ओके, तो जब भी एक कंट्रोल सिग्नल होगा, लोकेशंस डिफाइन होगा सबसे फर्स्ट में, और फिर कंट्रोल सिग्नल मिलेगा, किस टाइप का सिग्नल है, रीड है कि राइट है. इफ दैट इज रीड, देन वो मेमोरी लोकेशन की इंफॉर्मेशन को पढ़ेगा और उसको डेटाबेस में डालेगा. तो एफ एफ दिस यू कैन सी हियर, कैन यू सी दिस क्लियरली?
Yes, sir.
स्टूडेंट्स ओके, तो ये समझ आ गया है कैसे होगा। ये 8 बिट का डेटा है, ये 205, और यहाँ पे 1 पे ये है, 2 पे ये है, मतलब ये भी एक लास्ट डिजिट है एड्रेस की, 2050 और 2051 है ना। तो ये कोऑर्डिनेट है, तो ये 2052 हो गया। तो ऐसे ही जो भी डेटा है वो किस पे हो जाएगा, दैट डेटा बस पे आ जाएगा वो। क्लियर है चीज। Now you see the diagram here. So here you can see this A0 to A15 is address bus, and D0 to D7 is data bus, and this is the control bus. Though it is shown with a arrow which is containing lots of lines, but it may be डिफरेंट कम्बिनेशंस ऑफ सिंगल लाइंस। सपोज कि 4 लाइनें इसमें गई हैं, मेमोरी रीड मेमोरी राइट, इसमें कुछ इसमें लाइन गई हैं, इनपुट रीड इनपुट राइट। तो ये डिफरेंट सिंगल लाइंस विल बी एक्टिवेटिंग द सिग्नल कंट्रोल सिग्नल्स। हियर यू कैन सी दैट सपोज आवर एल्गोरिथम डिफाइंस पार्टिकुलर एड्रेस, एक पार्टिकुलर एड्रेस इन सभी को प्रेजेंट किया जाएगा, ठीक है। और now the address is available to the address bus, so it will definitely access all the devices, ठीक है। now अगर इस एड्रेस बस पे यहाँ पे कोई डेटा है, तो सबसे फर्स्ट में क्या होगा कि मेमोरी जब कंट्रोल सिग्नल मिलेगा मेमोरी रीड का, तो सपोज कि ये एड्रेस बस में मेमोरी में कुछ है, तो क्या करेगा, यहाँ पे इसको डेटा बस में डाल देगा। क्लियर। So internal data operations and the 8085 registers, two types of registers are there. You can see one register which is used in Ohm's law, RESISTER, okay, register, and this is register. So you must clearly differentiate between this, don't be confused. Registers mean where we do the entry, okay. Simply if we say registers are that where we do the entry or store something. So internal architecture of the microprocessor defines how and what operations can be performed with the data, okay. So depending on the instructions and the internal architecture, the data operations on the data will be performed. So there are different operations: storing the 8-bit data, perform arithmetic and logic operations on data, and test for conditions on the data. Suppose in the accumulator there is 0 0, so if 0, that is condition. If parity, if odd parity or even parity, means number of ones in this 16-bit 8-bit data. तो different conditions को check करेगा। Sequence the execution of instructions, it will sequencing, that means हर एक इंस्ट्रक्शन का एक सीक्वेंस डिफाइन करेगा in memory location, and store the data in stock. So here we deal with each of the system, each of the operations, and each operations will be performed by different types of registers, okay. So here you see the this is the memory. You can see more the clear structure of bus structure here. So this is another figure. So here whenever the control signals is there, the data bus, there will be a particular memory location. Here you can see The stack and program counter are 16-bit registers, which will also have some instructions. Here you can see that the some data or instructions will be some data will be saved in certain stock or reserved locations, so that is defined by stack. And this is more elaborated diagram of previous diagram. Now here we were discussing about the programmable registers. So registers are used for um, storing the 8-bit data. As we have seen that first operation is storing the 8-bit data. So how we deal with this? We have different general purpose registers, 8-bit registers, that is B, C, D, E, H and L. Okay, so the value of these registers can be modified or programmed when we want. We can change the value of these registers, or a programmer can use them to load or copy data from other registers. Suppose we have an instruction move B to move C to B. This is called the move C to B. Okay, then the content of the register C will be moving to the register B. Okay, so the same data that is in C will be available after this instruction in register B also. Another register is accumulator. I will show you in the simulator how these registers are there. Here you have the, you can see here B, C, D, E, H and L. 6 registers are there, which are general purpose registers for using the 16-bit data. Sometimes there is carry and we need 16-bit information to store. So because generally the registers are defined by uh, 8-bit, one register B is defined by 8-bit, C is defined by 8-bit. So we also use the register pairs for storing the 16-bit data. So here you can see B, C, D, E and H, L are register pairs which can also store the 16-bit data. Okay, so these are the general purpose registers. Now you come to the accumulator. Accumulator is the register which is generally used for all the arithmetic and logic calculations, and mostly all the data operations are performed in accumulator, and intermediate output, intermediate results in accumulator are shifted to the memory or other registers. Okay, so here you can see, I will show you the accumulator value. Here you have A, and PSW is a program status word, that is the registers made up of these flags. Okay, so accumulator has this data after operations or before the operations. तो अगर कोई भी मेमोरी लोकेशन पे है और हम परफॉर्म करेंगे तो वो क्या आएगा, लोड ए। अगर 2050 पर कोई डेटा है, 2050 पे कोई डेटा है, 2F है, तो जब हम ये इंस्ट्रक्शन करेंगे तो वो एक्यूमुलेटर पे 2F आ जाएगा। ठीक है, सपोज वी हैव सीन हियर, and all these instructions we are removing, and only there is one instruction. Suppose uh, now you see here that in accumulator you have data 2F, means this has been used for the arithmetic operations. If you increment I and A, or you can add the add B, then what you will see here, you will see here that the content of B and the content of A, that is 2F, has been added and it is stored itself in accumulator, that is 5E. So in this way we can see that the accumulator performs the arithmetic operations also. Means register A is used for performing the arithmetic operations. Next is flag register. Generally, the flag register includes the 5 flip-flops, and each flip-flop may change after instructions and after fulfilling the particular condition. So, 5 flip-flops are there in this flag register, and one is zero flag, carry flag, sign flag, parity flag, and auxiliary carry flag. Auxiliary carry is the carry which comes after the 4-bit, and carry is the uh, which comes after the arithmetic or logic operations of 8-bit, after 8-bit. So sign is the whether the data is negative or positive. So sign bit will indicate that if there is a zero content in accumulator, then this will represent the zero flag. Okay, zero flag is 1. Parity, even parity or odd parity, even parity 0 and odd parity 1 हो जाएगा. So each flag is a single flip flop, and depending on the condition of the um, algorithms, conditions of the registers, these flip flops will uh, change its value. So I will consider the this part in the next session. And students, could you understand the whole subject topic? Hello, can you listen my voice?
Yes, sir.
सब्जेक्ट टॉपिक समझ में आ गया है? जो चीजें
Yes,
हैं
sir.
जो मैंने बताई, किसी को कोई कंफ्यूजन? मैं तुम्हारे
No,
शब्दों में
sir.
बताऊं, तुम्हारे शब्दों में, तुम लोग शब्दों में बताऊं तो सर कंफ्यूजन ही कंफ्यूजन है. ठीक, लेकिन अब चलो ठीक है.